All right, hello, everybody. Welcome to the 32nd Rust Gamedev Meetup for November of this month. I have the post from last month's meetup here. I've been trying to put together like these little posts on the Game Dev working group that kind of show off the different talks that were happening and then give you like a link to go see it. But what I really want to get on is like actually making condensed videos for each talk, because I think there's a lot of really cool stuff that people are working on. We can toss it on like the Rust subreddit, and then people can check it out. And so always a lot of fun to see what's going on. Now this month we have quite a list of presenters. I think we have 3 games and then 1 engine, and so it's gonna be pretty cool to hear from people on how things are going. And so yeah, without further ado, we'll hop into today's schedule, because I'm not sure how long it'll take. I think we'll be going for a full hour and a half today, which is super exciting. And then I do want to mention afterwards, if you want to come hang out, we'll be in the Rust Gamedev Discord. I think there's like the Hangout channel there that we can chat in a little bit and hear what everybody's working on. And so feel free to stop by there after the stream today. So anyways, we'll be back in just a second with Ida, who is going to be presenting Mine Wars. All right. Hello, Ida. It's been a while since we've seen about Mine Wars and heard about it. So yeah. I'm super excited to hear about what's been going on.
So yeah, I wonder how many people here have actually seen this game before. I presented it like 3 years ago. I think it's been almost 3 years. Yeah, the first kind of functional prototype of this game that I had was back in Bevy version 03. It was very, the engine was very bare bones back then. And after that, it never really got very far, because, yeah, like I had to take a big hiatus for my mental health and personal life, and yeah, a lot of things have changed in life. So Mine Wars is multiplayer.
Sorry, I'm just gonna interrupt you for just a second. I'm getting a lot of mic static from your mic, I think, that I wasn't hearing before the presentation. So what I might just get you to do is just maybe reconnect the Bluetooth, and then we'll give it another try here and see if that fixes anything.
Or maybe I can kind of, you know, reduce the settings. Oh, it was on.
Oh, okay.
I'm sorry.
No worries, no worries.
I was using the wrong microphone.
Perfect. We're all good. No, we're all good. I'll leave you to it.
Okay, so yeah, Mine Wars is a multiplayer real-time strategy game that's based on Minesweeper. And the actual Mine Wars game mode I cannot show off right now, unfortunately, because I have some problems with networking. But I can still show a bunch of really cool things. This thing that I have open right now is my simple multiplayer Minesweeper mode, which is just like classic Minesweeper, except that it's multiplayer. And I can show off some of the cool Rust technology that I made to make it possible. But first of all, about the game itself. Mine Wars is on a procedurally generated map, which is like an island, like a continent, and there's mountains and some different geography and things like that. And in the actual game, there are cities that you compete for, and those cities produce things for you. They kind of generate income for you based on the territory you own. You can kind of think of it a little bit like Civ, where you have the surrounding region that are around the city, and based on the resources in that region, your city is going to produce stuff. And you can build buildings, you can build roads to connect cities, you can build towers and walls and things like that. And the goal of the game is to capture other players' cities. And you get eliminated from the game when you lose all of your cities. So you have to own at least one city at all times. And I'm just going to start another instance of the game for a moment because I want to show something. So every city has its surrounding region. Like if this is the city location here, there is the region around it. And you can see I have this highlights that shows it visually. And whatever territory you own around in this region is going to generate income for the city. And the money of your city you can spend on defensive and offensive actions. So you can buy your own mines that you can place on your territory to defend yourself. So if, say, for example, you had like some territory here, you could figure out some creative formations of mines that you could place in between the mountains here to block off the choke points and make your enemies have to solve a complicated minesweeper puzzle if they want to attack you and take your territory. So the micro gameplay, the moment-to-moment gameplay is basically Minesweeper. You see the digits and you need to figure out where the enemy mines are and avoid them. But also you can strike them to explode them. So you can pay some money to explode a certain tile. If there's a mine there, you'll destroy it. You can you can flag a bunch of tiles and then you can strike those tiles to destroy the mines there. I can't show it in action right now because it's not ready yet. Hopefully next month. The moment-to-moment gameplay is you place mines to defend yourself and you try to invade enemy territory to capture their land by figuring out where their mines are based on the Minesweeper digits. And things are made more interesting because they're actually not just regular mines, they're also decoys. And you can see, for example, if I switch to the player one view here. Yeah, so you can see some of the digits have an asterisk next to them. The asterisk means that one of those nearby tiles has a decoy. Or not one, but some of those. So like the digit 2 means that there are 2 items in the nearby tiles, but the asterisk means that at least one of them is a decoy. So at least one of them is actually safe to step on. And because I already know the mines here, based on these ones, I know that one of those 2 must be the decoy, and both of those 2 are actually safe. And I can just click on them and see I exploded the decoy. I broke the decoy, and now the digits changed. And I know here it's safe. And I know here it's safe. It's the Minesweeper puzzle. And here is not safe. But for example, I know both of these are safe because I've already flagged this one. And the asterisk means that one of these must be a decoy. So I can just click on them and destroy the decoy. So in the real game, you can plant both mines and decoys to make the puzzle for the enemy more challenging. And There's also another mechanic, which is a smoke. So you can deploy a smoke onto an enemy tile to hide the digit on that tile, and that way you can obscure some information from the enemy. And you can also place a trap, and if the enemy steps on the trap, it shows up as a decoy. And if the enemy steps on it, then all the adjacent tiles will get smoked. And so this way you can actually build some quite elaborate tactics for the moment-to-moment micro gameplay. If you want to defend your territory, you can plant creative formations of mines and decoys and traps and use smokes to obscure information when the enemy is attacking you, to slow down the enemy. And when you're trying to invade the enemy, you try to solve the Minesweeper puzzle and strike their mines. So every time there's an explosion, whether it's because you stepped on a mine or because you decided to strike those tiles, you will actually destroy the resources on that tile. And I think this is a almost kind of a cool political message, because by the end of the game, most of the map will be covered in craters from explosions, and most of the natural resources will be gone, and it will be like a post-war apocalypse, which I think is kind of cool. So you're fighting for territory, and you have these multiple players, and you're planting mines, and you're trying to blow up those mines and capture each other's territory and so on. And in the process, you destroy the resources on the land. And yeah, so this map is pretty big, you can see. Like in the actual game, I might have a bigger kind of casual game mode where you can have like 6 or 8 players or something like that on a big map like this with maybe say 10 cities, and you compete for like a big territory. And there could also be a dual mode where the map is small, like we can have a smaller map, and on the smaller map it can be just 1v1 with just 2 players. Yeah, oh, by the way, I forgot one of the basic game mechanics. When you step on a mine, it's not fatal, like in Minesweeper. When you step on a mine, you just get stunned. You have a timeout, like a 5 or 10 second timeout, where you can't do anything. So that's punishing enough, because in this game, every second matters. And if you step on a mine and you die, and the other players will be able to use your timeout to invade into your territory and capture a lot of your land, and you can't really do anything about it. And you only get permanently eliminated from the game if you lose all of your cities. So yeah, it's kind of, you need to capture those cities. They're like the checkpoints of the game. So there will be a scoreboard on the screen that says how many cities each player has. So you'll be able to see on the top of the screen here, like a mini scoreboard. Imagine like kind of the UI that you have in a game like Counter-Strike, where you have the player avatars here at the top, and you can see at a glance how many players are alive and things like that. So I'm still working on that, so I can't show it off today. So maybe next month, the game will be in a more of a complete state, and I'll be able to show off the actual Mine Wars multiplayer game mode. For today, I don't have that ready. So all I can really show you is just some basic Minesweeper. And yeah, one of the cool things that I did was I developed this Rust framework that allows me to playtest all the different player views within the same game client without networking. So this game right now is running completely offline. It's running just within the client, and I can control all 3 of the player territories. So I can just use F1, F2, F3 to switch between the different views and see what. So right now I'm looking at the green view to see what the green player is seeing. And now I'm looking at the blue view. So I see like what player 2 is seeing on the map. And this way I can check to make sure that all the game code is working correctly, because one of the most challenging things with developing this game is making sure that the game state is consistent for all players, because the server is only going to send each client the data that it actually needs. So every view has different data associated with it. It has its own different version of the game state. So it's very easy to introduce some bugs by accidentally sending some updates to player 1 and forgetting to send them to player 2, and things like that. And this feature allows me to debug and troubleshoot that. I can switch between the 3 different views and make sure that everything is consistent, the digits appear correctly, because these digits are not client-side, they are server-side, of course. So the server is sending updates to say what the digits should be on each tile. And yeah, keeping the game states, the game view consistent between all players is one of the big development challenges for this game. I can control whichever player I want. So like, for example, now I pressed F1 to view the red player, but I can press Shift F2 to control the blue player. So now I'm watching the game from the point of view of the red player, but I'm actually controlling the blue player. And if I press here, for example, I will be capturing land using the blue player. Now I can press F2 to view what the blue player sees, and I can now I'm both playing as the blue player and also viewing the game as the blue player. And now I can switch to the green player. So now I can play the game as the green player to all of this framework, I think, was very important to develop because it laid the foundation for me to be able to actually implement the complex gameplay of this game. The previous prototypes I had were very buggy, and it was enough to kind of serve as a proof of concept and for me to be able to play test some of the basic gameplay with my friends, but it was not enough to be released to the public. So that's why I've never released a demo of this game. And for this version of the game, it's kind of a half rewrite. I'm taking a lot of old code and reworking it and rewriting parts of it, and I'm trying to lay better foundations. I'm trying to avoid technical debt. I'm trying to set everything up so that the architecture for both the client and the server and for the gameplay code and for the graphics and for everything is flexible enough for me to be able to debug everything and play test everything, because I want to actually implement this game properly. And there is a surprising amount of complexity that comes up when you try to write some game logic on the server, and it's a multiplayer game where every player has a different view of the game and different information. The information is asymmetric. So you're not just trying to sync some entities between client and server. You're managing multiple different points of view and sending each player their relevant information. And you have to do it in a way that's going to make sure that they're not going to be able to cheat at the game. They're not going to get any information that they're not supposed to know. And you also need to do it in a way that's consistent, because if you accidentally send the wrong digit because you forgot to update it when something else was updated, that will be misleading and it will be a bug in the gameplay. And it's very easy to introduce such bugs. And yeah, the idea for this game started originally as I'm going to make a multiplayer Minesweeper, but I don't want it to just be the boring multiplayer Minesweeper because that's already been done before. I want to make a more interesting strategy game where you actually have an objective, and it's not just about the Minesweeper. The Minesweeper is the moment-to-moment combat, essentially, but I wanted to make it more interesting. And up until last year, the gameplay actually involved like chained explosions and things like that, and you could cause a mine to explode and take out nearby mines that way. And then I realized that that's too overpowered and it actually breaks the game. So we redesigned a lot of the gameplay mechanics with my best friend this summer. We spent the summer brainstorming and basically redesigning the whole game. So the original idea was to be able to move mines around. So as you capture territory, you capture the mines on that territory, and now you can move them around and reposition them. And that evolved into being able to put them into an inventory and having an inventory system where you can remove the mines and then deploy the mines. And then that evolved into a shop system where now in this version of the game that's not ready yet, in the next version of the game, we're going to have a shop and we're going to have an economy where instead of moving mines around, or instead of having an inventory with a certain number of mines, a certain number of decoys or whatever, you just have money. And the city is generating income, and then you spend that money on gameplay actions. You buy mines and decoys with your money, and you can also perform offensive actions like deploying smokes or striking certain tiles to cause explosions and take away enemy mines, or construct buildings and things like that. And you do all of that with the money that you accumulate over time from your cities having access to natural resources like the mountains and the forests and things like that. And the way you capture things in this game is by surrounding them from all sides. So, for example, when you reach an enemy city in Mine Wars, say you're starting from here, and you expand, and you reach the enemy city, you need to capture all of the surrounding land and hold it for 5 seconds or 10 seconds or something, and then you capture the city. If you want to capture a mountain cluster, you have to surround it on all sides, so you just kind of capture the surrounding land. The actual mountains themselves are not playable. You cannot get any digits, you cannot have any mines or anything. The mountains and the forests are resource clusters, so you own them as long as you own the surrounding land. And you can and they will give you money every second. So for every tile you own, you'll get like +1 or +2 or +3, depending on the tile kind, every second. And then you can use that money to play the game, to buy mines, to strike tiles and things like that. I think it's going to be a very interesting multiplayer experience. It's going to be quite unique. I've never really seen anything like it. It's not just multiplayer Minesweeper. It's an actual multiplayer strategy game. And it's not a typical RTS either, because you don't really have units. You don't have things like health bars and armies of units that you move around and things like that. You're basically playing Minesweeper, but also it's about the strategy. It's about making use of the geography of the map. It's about being able to place your defensive items, being able to place formations of mines and decoys, being able to think faster than your enemy, being able to solve the Minesweeper puzzles faster, building road connections between your cities so that you can share the resources between them, building walls and other defensive structures. It's quite an elaborate game, and I'm really looking forward to be able to play this new version because it evolved so much. The old version of the game was kind of boring. It was just a multiplayer Minesweeper with chained explosions and being able to move the mines around. But now it will actually have an economy and more of a strategic aspect, because yeah, I don't want to just make Minesweeper. I want to turn Minesweeper into a cool strategy game where you have a meta game. You have you can think about different approaches to the game, about controlling territory, about map control, about positioning on the map, about multiple front lines. When you have borders with multiple enemies and they could attack you at any time, and being able to lay your defenses and so on. And I think it's going to be really cool. So I don't know how we are on time. I think I'm running out of time. But if anyone's interested in specific technical things about the game, like the frameworks that I've implemented for this playground mode and multiplayer and things like that, I think now's the time to ask questions. I can show you some of the Rust code if you want. Yeah, the game is partially open source, by the way. So by partially, I mean that the game client is open source, and the frameworks are open source, and all of the Bevy code and things like that is open source. But the main Mine Wars game mode is going to be proprietary. So I can make a custom build of the game where I enable the proprietary extra features to have the full-featured game client and game server that is able to play the proper multiplayer game mode. But you can also just clone the GitHub repo and make an open source build. It's not going to be able to play the actual main game mode, but it's going to be able to play back replay files, and it's going to have all of the graphics code in it. It's going to have most of the technology in it. So if you want to learn from my code, if you want to copy some stuff into your own projects and so on, most of the pretty much all of the technology and the foundations for this game are open source. You can copy the tech. I'm just keeping the main game mode logic, the main gameplay logic proprietary.
Perfect. So we are running a bit short on time because we do have quite a few presentations, but oh my gosh, do I ever want to talk about this? Like I'll ask one question that I was thinking. And so I really like that it's like real time and you're doing Minesweeper. And I have those friends who, when they play Minesweeper, they just like click, 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 like just they see the puzzle, they've solved it. And so I really imagine that like at a high level of gameplay, it would be so interesting to like zoom out on the map and see how people are like just like traversing it so quickly. Now, what I'm kind of curious about is what would this game mechanic, or like this sort of mechanic style, work well if you had 3 people that were on the same team and 3 people that were on like an enemy team, as if it was like a, I don't know, like some competitive game.
Yeah, so I have all of the groundwork laid down to be able to experiment with all kinds of different multiplayer dynamics. The code supports it, and I'm going to do it. One of the things one of the ideas I have is to have alliances. So you could start a game, and when you reach another player, you could propose an alliance, and you could say, hey, let's be allies. And if the other person accepts your alliance, now you can see their entire territory. You have shared information, and the game will protect you from attacking each other. You will not be able to attack each other's territory, and you'll have shared visibility. So you'll be able to play the game together until you break the alliance. And you will also have some communications, like maybe in-game chats and maybe voice communications, if I can get that working, if I can figure out how to implement it. And also, I will have another game mode which is inspired by a lot of the recent battle royale games and so on, where you can have like duos where 2 players are controlling the same territory. You join the game with your friend, and you're playing as the same color, controlling a single territory. That's also an option that's supported by my code, and it will be very trivial to enable. And I'm really looking forward to experimenting with all of these different multiplayer dynamics. I think when I release the first public version of the game, I'm going to be able to have the regular competitive game mode, which is, say, for example, going to be like 4-player elimination match. And with a lot of also neutral cities on a bigger map. So there's some of the cities start out neutral, and you can go and you can capture some cities without engaging another player immediately. I think I'm going to have a mayhem or like crazy mode where it's on a more claustrophobic map where there's exactly 1 starting city for each player. You have more players, and you have to immediately engage another player to progress into the game. I'm going to have like duels. I'm going to have duels where 2 players play as 1 territory. And I'm also going to have a casual mode where you can hop in and out at any time. So like players can join mid-game and drop out mid-game from the casual mode, which is going to be really nice, because I suspect one of the initial challenges for this game would be growing a player base. For a multiplayer game, you need players. And if you don't have many players, you can't really do matchmaking. You can't really have proper competitive gameplay, because nobody is going to be able to... People are going to want to play the game, but there are not going to be enough other people to play with that are online and ready to join a match. So I think the casual mode is a good solution, because you can just hop in and out of it anytime, and it doesn't actually need to find a certain number of players to start the match. Okay. So you'll be able to play casual while you're waiting for your competitive match or something like that.
Yeah. Okay. Yeah. So I really like these like multitude of different ways to play, and I imagine that there's like some higher level abstractions that allow you to say like, oh, I want to change the game mode a little bit. I want to make these small tweaks, and I just have to change a few lines, not like hundreds of lines. Is that sort of how it is?
Everything is very configurable, and that is the reason why I kind of did this half rewrites instead of just iterating on my old prototype. My old prototype was very just kind of set and baked into the code how the game should be, and very inflexible to continue further development. So now with this new version of the game, I've taken a lot of care to avoid that sort of technical debt, so that everything is very reconfigurable. It's very flexible. The game as it is right now, you can easily make an offline mode that is single player, an offline multiplayer mode like the one that I'm just showing you here. It has no networking, and you can control all the players from one game client. I can make you can play on LAN. You can host your own server very easily. You can change all the game parameters. You can decide how many players per territory, how many clients per territory, how many like the map generation parameters and things like that. And it's very easy to tweak. Mm-hmm. So my main priority with this version of the game, the reason why I'm doing this rewrites is because I want this flexibility to be able to play test a lot of different variations on the same gameplay concept, to be able to organize a LAN party with some friends here locally and get a bunch of people to play the game and try all kinds of different variations on the same game, with different numbers of players, with different map sizes, with different number of cities, with say some different mechanics enabled or disabled and things like that.
Yeah. Okay, yeah, it sounds like it'd be super fun in the upcoming few months, and so I definitely want to hear about it again. I think it'd be so cool if we could like sort of see how it plays with like multiplayer and stuff like that. And so I definitely hope to see you in future months to hear an update on Mind Wars.
Yeah, I think I'll be here next month, and after that to show more progress, hopefully.
Perfect. All right, well, Ida, thank you so much for coming out today, and we will be back in just a few seconds with Kvark, who will be showing off Blade.
Hello.
All right. Hello. Kvark, I'll let you take it away. You've shown off Blade a few times already, and I'm super excited about to hear about what's been going on. So go for it.
Thank you. I'll try to be short. I've introduced Blade as a low-level graphics API, and the point of that was that it's very fun to hack on. It's very ergonomic, and why not use the fun to build something interesting? So I've been talking about the asset pipeline on the last Gamedev Meetup. Now I'm going to be talking about the next stage, which is like proper rendering and scene editing. So this is our README. Some of the demos, if you haven't seen them before, and this is my small helper slides. So first, we're going to talk about denoising. If you remember last videos I showed, they were very grainy. You could see noise on all the surfaces. So here's what we have today. You can see it's pretty smooth. There's no like jumping of brightness in pixels. It's very stable, and it's real-time ray tracing. Like I can fly through that, even though I'm streaming this from a weak laptop. It's not a game laptop. I can stream and at the same time render this picture with real time. The only noise you see is the one where pixels become visible which are not visible. Like, for example, look at the left of the screen. I'm going to turn. Yeah, there's a bit of noise on the left, bit of noise on the right. And that's because I'm aggressively using information from the previous frames. So there is a temporal reprojection that happens both during the restier part, which I think I mentioned the other day. That's the NVIDIA's magic sauce for proper ray tracing. But also, I'm doing reprojecting during the post-processing pass for smoothing everything out. There is a paper showing what I'm doing here. It's the SVGF paper. And in order to help you understand what's happening there, I'm going to disable all of the features I have. Disable denoising. And disable the temporal resampling and spatial resampling. So what we see here right now is a very noisy image, which is just a result of every pixel casting one ray into the direction importance sampled from the sky. So it's not a completely random direction, more or less random, because the sky is all bright. It's extremely noisy. Now, if we start temporal reprojection from this, I can crank it up to a level where it's almost good, still not very good. But we are going to start with one sample here. I'm using eGUI on the right to configure this. So this is way less noisy. And I can measure the noise actually. Here you can see standard deviation on the right. It shows the actual noise on the pixel I just clicked. So I can confirm not just visually, but also with numbers what I'm feeling about the scene. So this is like 0.2, 0.3 kind of noise. Now we're going to enable the spatial reuse for the reservoirs. And you can see even less noise now. And let's see if the numbers are going to converge. I think they're already lower than what we had. Like we had 0.2, 0.3, and now 0.18. And visually, you also see that it's much better now. There's no, there's a bit of a problem with movement, but not as much as we saw in the beginning, because it's just one reprojection. It's just helping. But this is the result that you cannot ship, obviously. So this is where when people say we can't do real-time ray tracing, this is what they mean. Like this is best you can get, or around in the ballpark of real-time ray tracing without doing denoising. But denoising is not the worst part. Like, look, I just enabled the noise, and it's pretty cool. It's smooth. There is still texture detail on the surface. Oh, I'm in the wall. There's still texture detail on the surface. You can still see all the features of the scene, and it feels like it's just rendered correctly and just faster. So denoising is like a bit of a magic, and my denoiser is very basic right now. It looks at the depth and normals, and it separately blurs diffuse lighting from the albedo of the textures, so that we can still see the texture properly on the surfaces. Like here on the top, you see that the roof is still very, very nicely visible, and it does the temporal reprojection. So it's an interesting piece of machinery. If you're building your own ray tracer, I would recommend just looking at my code, because there isn't that much. You can easily port this to your own ray tracer. And of course, we can do much better than this. There's lots of stuff we can do to make it nicer. But this is fine for me. I want to see how I can get something moving, get something flying or jumping or like driving on top of this, because it's already looking well enough for me. So the next thing we're going to talk about is Gizmo. And I'm going to not load the sponsor scene and instead just load the example, slightly modified so that we only have a plane here. This is just a plane. What we're going to do is we're going to go to the GLTF sample models and say, okay, core set. Let's go to GLTF core set, and we're just going to drag it on the scene. Boom. Where are you, core set? Oh, here you are. Very small. So there it is. Now I can right click it. Now you can see some interesting artifacts on the bottom. I haven't figured out what's happening there. Some future work, but that's not the point I'm trying to show. So I right click it. I see on the left there is a list of objects. There is a scene name. There's a list of objects. There's a plane, and there is a core set, and it has translation, rotation, and I can just I can just move it. I should be able to just move it. Oh no, look like I broke it in one of the updates. Feels like I was tweaking something and I broke it. Oh, that's embarrassing. Don't tweak too much before showing your stuff. I guess that's the lesson here. But what we're seeing here is EGUI gizmo, and it allows me to manipulate objects. I think while this is happening, I'm gonna quickly load something like this. So where we're talking. So EGUI gizmo is this wonderful thing that allows you to show the gizmo, which we just saw, and manipulate objects. And I integrated EGUI in the engine a while ago. I was showing some EGUI before, and now I have gizmo integrated as well. It's very good for scene manipulation. So I have a list of objects which I can just drop in more objects onto the scene. I can move objects around and rotate them, and I can save and load the scene. That's the basis of the editor, basically. It's gonna finish compiling in a second. Linking is unfortunately taking time. All right, here we go. Okay, so in this revision, we had the monkey head still. That's fine. Just gonna drop. So it's cooking the asset now, which is expected. In this version, I think I didn't compile with the dependencies with optimization. So the cooking of the asset is a little bit slower than on the version that I was showing you. Some of the hacks were actually useful, guess not. And it's also showing the black screen while cooking, which is something I fixed in the latest as well. So I'm gonna let it cook. This is most of the time here is taken by just compressing the textures into the DXT format. I'm using Texpresso for this, and Texpresso is notoriously slow if compiled in debug mode. So that's something that's gonna just take some time for it to process. It's doing multiple textures on different threads, which helps, but it's still, it can take like 30 to 60 seconds for a texture for Texpresso. So something that I recently did is just switching it as a dependency to always be optimized, which makes everything much nicer. Okay, so hopefully we can see something here. I'm gonna maybe show a bit of this while we are looking, and maybe look ahead in my slides to see if I can talk about something. Yeah, we talked about the ability to drag and drop. I think it's just a matter of showing how it works. So presumably, if we come back to this and this works, we can I can talk about some of the features that I want to get in the next phase of the project. So one of that is that my scenes right now are just hand-defined RON files. So they're certainly deserialized files that you can hand edit. And I'm thinking if we can use something more standard like USD, it seems like it would be a lot of work. If you have worked with USD format from Pixar, I'm curious if we can get something rolling in Rust, because in C++ there is at least a library that allows you to parse the format, and it's not Pixar giving like a third-party library. It would be nice to have something very Rusty here, something like winit, but for USD, something we can all use. The other thing is I was talking about like how ray tracing features are implemented and how it's all real time. But I only support very limited set of physical effects right now. So I don't do any specular reflections yet. And I know that specular is going to be difficult and it's going to make it slightly slower. I would need to cast an additional ray potentially from every surface because it's the like BRDF driven ray. If you have a perfect mirror, you don't want to sample the sky where the sky is most bright. You want to sample the sky where your reflection is going to go from. So it's a different kind of sampling routine that I will need to do. And of course, I want the local lights to be supported. And by local lights, I mean anything that can emit light. It's not actually a point light that you place somewhere. It's more like this object on this material needs to emit light. So it serves as a light source. And if you need like a street light or something, it's also a mesh. It's just an object with an emissive material. And all of the other objects will need to consider sampling that light into them to do anything useful. Okay, that's interesting. We're still doing some cooking. The other thing I wanted to mention is that pretty much everything is ready for the release. Obviously, I need to fix the Gizmo thing, and there's a few libraries that are still publishing, like the Zune library is providing the image decoding. And once it publishes all of its crates, I'm going to release Blade 0.3 series of crates. And this is going to be, the crates included are Ego integration, low-level graphics, the rendering, which is like the ray tracing meat of it, in the asset pipeline. I don't expect it to be widely useful, but it's good to play with, I think. Okay, it's not, I don't know what it's doing right now. Oh, it's, yeah. Okay, it's not doing well. So what happened is that I broke things repeatedly for multiple ways. So once I broke it so that local textures are not read properly, and this is one of the features also important that I was implementing that allows you to drag and drop GLTF files with built-in textures. Oh wow, what's happening? What is happening? Everything is broken.
Yeah, I think like the last several times I like demoed a project or something, like I don't know, you feel like you can just keep committing right until it's ready to go out, and then yes, you very much realize that everything is not going
well. Wow. Yeah. Wow. I don't know what's happening. Maybe I need to come next time and show this.
Oh yeah. I love when you come back. It's always great hearing about Blade. I'll give you some of my stream of consciousness while I was like watching it. I think one of the coolest things about Blade that I see is like the artifacting could actually be such a cool effect to have. Like if you have like a horror game or something where like the way that it's rendering is something that you'd want to add in post-processing anyways, or you could like use that as a constraint, that it would be so cool to use Blade because if I'm not mistaken, it would give you some really high fidelity graphics at a lower cost than alternatives, right?
Are you talking about the visual artifacts or just the ray tracing pipeline?
Well, I guess like the ray tracing pipeline is like, if I'm not mistaken, it's like a lot more efficient than other ray tracing pipelines, right?
Yeah, it's like it's real time. Again, it's a very it's a weak business laptop that I'm running and streaming at the same time, and it's running real time basically. So you can, if you have any kind of discrete NVIDIA GPU, it's gonna fly on your machine.
Yeah, because I think like definitely there's a lot of games that I could think of that have an aesthetic like this. Like, so I mean, like one of my favorite ones is like Return of the Obra Dinn, like the way that everything is sort of in 3D. It's like pixel point art, I guess, pointillism. And then similar with this one, like as you move your camera around, like stuff kind of like comes in on the outsides as it like gets, I guess, like the denoiser goes across it and stuff. I can certainly see that games would like to have, or like could definitely build around this type of artifacting.
Yeah. I think I know precisely what you mean, and the number of different weird visual effects you get for ray tracing is amazing. So I don't know if I have maybe I have something like this. One of the effects I enjoyed greatly was, oh no, I don't think I have it. This is some of the stuff I was playing with like just spawning a bunch of buggies and rotating them. Something I wanted to show, but I can't. But if you get the reprojection slightly off, just a little bit off, what you would get is that pixels are gonna slide slowly in time, and it looks like a rainy surface that like there's just water flowing through it. It's amazing. So there's so many visual things you can do, and the stuff that you mentioned, just like disocclusion noise. I'm looking forward for the day where this is actually solid, fixed in the engine itself. So engine will just realize that, oh, for this pixel, I need more information. So I'm going to like cast more arrays or do more aggressive spatial search or something. And then like, it's going to look perfect. But then on the game side, you're going to like simulate the same thing and basically
exactly
re-implement the noise that's otherwise be in the game. Yeah, that would be good.
Yeah. And actually, just out of curiosity, for like downstream someone using this, is this something that you can like put into either WGPU as a backend or into something like Bevy as the rendering backend? Like where might it fit in different projects?
Yeah, good. If you're talking about ray tracing part of it, you can technically port it. It's probably going to be easier to not port the blade render crate itself, because there's not much Rust code in there. All the magic happens in the shaders. So what you need is and it's using Wixel shaders. So the only caveat here is that in shaders I'm using ray tracing features that I landed in Naga. So they are not standard Wixel features. If you're using Naga for your work and you target Metal or Vulkan, then you can just port my shaders to your engine and get something similar. Yeah.
Okay, that's super cool. So it's kind of composable from like a lower level than necessarily the entire engine. Like you can take different parts here and there, and so I guess like the main idea here is that what you've done is implemented the research paper that's talking about all these cool and novel ideas, and you're kind of seeing how it would work in a full engine form.
Yeah. Of course, it's not just research. It's actually trying to make the code readable, because if you read the paper's code, it's amazing how research scientists they don't care about engineering this. They care about the final outcome, and their code is often unreadable. Yeah, I think my code is very readable, and it could be a good source of learning. And I also talked about another thing that I did a while ago, which is like ray tracing on the ASCII terminal. Remember that one? It's like ray tracing playground. I think I showed it where this was meant to be educational. I don't know if I'm going to port all of the new things in there, or people can just look at this project and instead learn from here.
Yeah. Okay. This is very cool as like, I guess, an educational step for some of this more complex rendering side of things. Is there anything else that you want to go over today?
No, I think I'm gonna go back to fixing things.
All good. Sounds good. All right. Well, thank you for coming out and showing off. I think it's super cool to kind of be able to see what those steps look like when you go from the base version to that process of resampling and then denoising. It's really cool to kind of see those sliders.
Thank you for having me.
Yeah, absolutely. All right. We will be back in just a minute with Vlad, who's going to be showing us Jarl. off. There we go. So hello, Vlad. You are here to show off Jarl, and this is something I forget where I came across it. I feel like it was either in the newsletter or maybe on Reddit or something. But then I hopped onto your Discord. I took a quick look, and I'm like, oh my gosh, I'm super excited to hear about this. And so I'll hand it over to you to tell us about Jarl.
Cool. So yeah, my name is Vladimir. I'm going to present about a product called Jarl. You can also call it Jarl. It's a colony builder / simulator in kind of fantasy Viking world that I'm making with Bevy and Rust. And if you're curious, you can follow this like social links and learn more about the project. I guess I will start with maybe like talking 1 minute about myself. So I've been coding for like roughly 15 years. I don't have like any experience in game dev. My background is in kind of like natural languages, ML, backend data, and stuff like that. And a couple of years ago, I got really interested in learning Rust and graphics programming, and I started this project as a kind of like hello world to try Rust and some shaders and things like that. And it evolved into something I'm going to present. So let me start. I have a couple of slides. Let me start with kind of like a brief product summary. Like I said, it's a colony builder, and it's inspired by games like RimWorld, Valheim, Majesty, and stuff like that. It's like a pet project, which I'm developing solo, and sometimes I also collaborate with one external artist. Like I said, started a couple of years ago to learn Rust and graphics programming. Originally, I actually was using GFX or Rust, but then I ported it to Bevy and WGPU. It runs on PC, Apple devices, and Steam Deck. And a lot of people ask about multiplayer. Maybe there will be some multiplayer, but I don't have like any information to share right now. And in the game itself, what player can do, the player can have controls a character. It can explore map, interact with like different objects or creatures on the map. It can collect resources, like fight with monsters, and the center of attention will be like a colony that you can build, defend, explore, expand, and like interact with all the NPCs that are living in your colony. And I'm going to talk about like three main parts that game built on top, and we'll try to explain how they are implemented. So the first part is like a world map, and like in terms of like a data model, world map is pretty simple. It's just the layers of integer grids that contain information about like surfaces or some regular objects like walls and mountains. And in addition to integer grids, you also have like a list of entities, like irregular structures, like, I don't know, some furniture or stuff like that, and different creatures or characters on the map. On the right side, you can see UI of LDTK that I used to kind of like edit the map. It's not the only way to generate the map, but it's really handy for debugging. Essentially, it's a tool which you can use to edit those grids or entities, and then output the result as a JSON with all the metadata about like tile sets and other stuff. And on top of this data, you like three important things for the map are tiler, spatial index, and navigation grid. So the tiler is essentially just like a functionality that giving surroundings of some tile, it will tell you like what should be the sprite of the tile. And it's important to kind of like decorate the map and like make transitions nicely between different like sprites. And auto tiling rules is also something you can create in LDTK, and I'm sure there are a couple other tools for that. The other important part of the map is a spatial index. It's basically a system that can answer questions really quick, like given like location and radius, give me all the items or creatures or line of sight blockers or something like that. And the spatial grid system I use is really simple. It's just like a regular grid where for every cell I store a list of things, and then we recomputed every frame for like all the dynamic things, and for static things we just track when something was like spawned or deleted. And the last part that is kind of essential for the map is navigation grid. Again, really simple. It's just like a lattice structure grid that can quickly generate the path between A to B, and it's used, as the name suggests, for navigation of the characters. So the next important part of the game is like items and structures on the map. They are also extremely simple. The main thing about them is they're very asset driven. Like on the right side, you can see like how they represented in meta file in run format, and every time you change something, you can it automatically reload it, and you can play with like different characteristics of items or structures. You can change the graphics or like play with parameters, and it's really, really handy to have that part of the game asset driven. And in terms of how they represent it in the game, it's basically just like one entity per item, structure, or like block. And to spawn or like delete them or like do any interaction, it's really handy to use command pattern to like send events, and then some system will handle them. And we'll talk about it a little bit more in the next slides. And the creatures are a little bit more complicated. So they similar to items. They also asset driven, but there are two kind of like important things about them. They have AI part and they have animator part. So the AI in this game is very inspired by how AI is done in the games like RimWorld. So you have like two levels. On first level, you have things like job givers, planner, and tracker. And job is like very, very high level description of what creature should do. For example, should it like go somewhere, haul things, or attack someone, or harvest resources. It's like very, very high level. Doesn't really tell how to do it, but just tells the character that it should do this. The job giver is the system that answers the question who should do what at what time. It basically tells the other systems like, hey, this creature can like defend if there's enemies around, or it can go and recover if it's injured, or it can go and sleep if it's like a nighttime. So the job giver just can enable all of these actions for a creature. The planner is a thing that reorders all of these jobs that were assigned to a character, and it's like a ranking system, and you can plug things like behavior trees or GOP or maybe like some fancier machine learning algorithms to decide what each character what's the most important thing for character to do at any moment. And the last part of this, like a high level, is a tracker, is essentially where you store state for each creature, like all the jobs assigned, what's the most important job at this moment, and what are the steps of that job. And so for AI, the next level are steps. Steps are like extremely detailed, like a physical things that characters should do at every tick of the game. And there are only 2 steps in the game, and everything else kind of like described through them. There's a navigation step that tells well, from how to go from A to B. It's like a place where, for example, the character computes the path, maybe follows some formations if there are any other units with the character, or this step also contains information like how to complete navigation. Is like, should I be in some area, or should I just touch something, and stuff like that. So it's very configurable, but there are only 2 of these steps. And the second step is play animation. Again, it's extremely configurable, so you can tell like what animation to play, what's the like a play mode, like is there like any speed up for that animation, or things like what else should happen when I enter that step or when I finish the step. Like, for example, you can say equip the weapon when you enter attack animation step, or you can tell like find a tool or pick up item or stuff like that. So it's like only one type of the step, but you can customize it for some very specific tasks. And the step runner is just like a system that can read the current step of the creature, update it, and then update like a physical word. Like, let's say tell movement systems like what's the forward vector for this creature. And the second big part of Creatures is animation system. So on the right side, you can see how animation is represented in a sprite. Basically, it's layers of frames, and for every frame, you can also have like tags that tells the three things like action, direction, and like events. So the way Animator works is it has like two types of events. Like you can send event to tell Animator, like an internal event, like to tell Animator if it should like play some specific animation, or should it reset to default animation, which could be like idle. Or you can tell Animator to enable or disable layers, and you can, for example, say when you pick up some item, like we will enable the layer for that like armor set or something like that. So it's really handy. And also Animator can, while it's playing animation, it can output events to the external kind of like systems. So for example, you can tell Animator to spawn a hitbox on a certain frame, or start like a sound or some particle effects when you, for example, walk on certain on a certain surface. So it's just very kind of like handy to structure it like that. So far, Sprite was working okay for this kind of stuff, but maybe later we'll switch to like some better authoring tool for this. And there is a third system that's kind of related to creatures, is avoidance system. I'm not going to talk about it much. It's pretty simple. If navigation system kind of like creates like a rail for a character to follow, avoidance system tries to make sure it doesn't bump into some dynamic obstacles. So those were like three systems, sorry, three big areas of functionality in the game. And now I'm going to kind of like share how it's built with Rust and Devi. So like I mentioned in the beginning, I'm using Devi, which was working really well. And I'm using ECS, app, asset, built-in UI and text renderer, and render graph. And I'm also using a couple of third-party plugins, Rapier, Hanabi using, and Inspector. And the cool part is Hanabi using also made by same person. Other than Bevi plugins, I'm also using like some other crates to do like integration with fmod, have like some nice features for enums, sortie, as you can tell, and parse ASPRAD files. The way ECS system is used is basically for everything that all the functionality that needs to run and update a lot of entities, like almost all of them in the same frame or on the same tick, I put it into systems. Like you can imagine like AI and animation are done as normal ECS systems. But for things that happens really rarely, like, you know, spawning something or deleting or doing some interaction, it only happens on a fraction of entities at a time, and it's really handy to implement it as events with like a command pattern. So another cool thing about events is if you try to, for example, implement spawning an object as a method on some, you know, some function, or sorry, on some struct, spawning an object will require, like in reality, a lot of input information. You can think of like assets, some graphics, some like precondition checks. So it's like unsurprising if it would be like 20, 30 parameters to do that. So if you think of like putting spawning object call into multiple places, it's really not that ergonomic to pass all this like information in that call. But if you move it to its own event handler and you can send events to that handler, it will be like a lot easier to manage complexity that way. So events also used to kind of like implement factory or dependency, or avoid really complicated dependency injection. So those are things that work really well, and things that don't really well so far with Rust and Devi is, I guess, not surprising for everyone. There's like a lack of good UI solutions for us. It would be really good to have something asset-driven for UI. Right now, if you build UI with Devi or most of other frameworks, every time you change something, you have to recompile. And recompiling Rust programs isn't really fast. Like if it takes like 15 to 20 seconds, it's all it can kind of kill your imagination and be really hard for iterating on something. The second problem is also a lack of for this particular project is lack of animation and authoring tools. Like if you want to combine your animation with like certain like hitboxes or hurt boxes or like any other metadata, there is just no tool for that. Maybe I didn't find anything. There is like a tool called Tiger, which was the closest, but it's still in very early development. The last part I want to talk about is some custom quote-unquote tech I built. So in this game, I use like a custom renderer for all the lighting, and it's basically based on ray marching. It works with both direct and indirect lights. And the way it works, we compute SDF, then we split split our screen into 8x8 pixel probes. We compute direct light only for one random point in each probe, and that point is jittered between frames. Then we kind of like resample it to get indirect light. And when we do resample, we take into account like occluders and all that information from SDF. Then we accumulate 8 frames from the atlas and apply some kind of like a denoise. Here it's like basic lateral filter converted to sRGB because the other targets are in sRGB. And then we compose it with all the other layers with like sprite information, and then we do some post-processing to kind of like I don't know, like add custom effects. And that works so far pretty good. It can run on anything that's at least has like a 1060 performance or higher. It's like not the fastest implementation, but it works okay for development. There are better techniques like recent Radiance Cascades that worth to try. They're much faster than that. Maybe that will be implemented in one of the future versions. And that system is open source. You can find it on my GitHub. And it kind of in the game, it gives this kind of like soft, light, grounded, cozy look that I think adds a lot of atmosphere. And that's all for the presentation part. And I want to just give a quick demo of the game. Just want to double check. Can you see my screen?
Yes, all good.
Perfect. So I'm going to be doing demo using Stadia controller. The game can run with keyboard and mouse, but it's just easier to use controller.
Sure. We have one person just mentioning love the 2D lighting, and I think that's like one of the first things I saw as well. Like, okay, now we're seeing it here. Oh my gosh, it's so cool. Looks like the effects that are on the screen. It makes it look really different than other 2D games, I think.
That's nice to hear. So this is how the game works right now. I wouldn't even call it a game. It's kind of a pile of different functionalities. It's not like really connected right now into something playable, but you have like all your debug layers that you can use to like enable like different information, like occluders, navigation grid, and stuff like that. So that's like very handy for debugging. Then you can control the day of time of the day. You can like customize color and something else, and then there is like a UI to change the lighting effects. Like if you add, I don't know, more direct light and subtract indirect light, you can configure it through this UI. So we control a player in the game. So we control a character in the game, and like we can walk, pick up some stuff, and we have like a very basic UI where you can see what's currently on a player. And once I pick up some item, you can also have like a quick access to all your inventory. And if I pick up the tool and select it, I can also see things that I can build. Like, for example, you can build stuff like walls and maybe add some more lighting. And I can also try to break it, and then it will spawn some of the resources that were spent on it. The other part, and let me make it a little bit brighter, the other part of the game is other creatures and NPCs, and the AI part of the game I was talking about, it goes through major overhaul. So not everything is yet implemented, but you can say like you can basically navigate. There's like no job giver, so you need to, right now, the debugging mode, you need to tell your character what to do. So you can tell them to navigate or attack some monsters, or for example, harvest resources. And this will work exactly as I was explaining. It will create a job that I can even show in the debugging layer. And then that job will be prioritized. It will be turned to specific steps. Sorry, the jobs are, I think, here. So for example, you can see once I tell it to collect resource, you can see the current job definition, all the parameters, and then the job runner, or so step runner, will go through all the steps and tell exactly what to do at any moment. And I can probably show stuff that is animation driven. So right now I enabled hitboxes and hurt boxes, and once I play attack animation, you can see like on a certain frame, it spawns a hitbox at the place where I'm aiming right now. I think that's all. And I wonder if anyone has any questions.
Okay, so yeah, this is super cool. I really like seeing like these debug layers of everything that you have combined together. And so like as you go and attack something, or you go and do a job, then you can see, okay, like what's on the queue, what's happening there. And so one thing that this definitely makes me think of is like the way that I hear about the development of Dwarf Fortress is just add more features, add more features, add more features. And I'm kind of curious, how do you balance what you're doing here with end user design? And so, for example, if a player were to come along and like try this out and play it, how are you balancing the complexity of like the job system or anything else that's happening in the world with what their goals as a player are?
How do I balance in terms of like priorities to what build next?
Well, maybe like as a player, if I were to come play this, like what's my experience geared towards, or like what's your intention for my experience?
Got it. That's like something I probably can't really answer right now. Like I would say I have like some goal that I want to make the project feel like, and then like every couple of weeks when I have time to work on it, I kind of prioritize things like and try to figure out what's more important, and then I experiment. So a lot of here is a result of like trying certain things in multiple ways until it starts feeling good. So for example, a couple of like months ago when I was experimenting with building mechanics, my first idea was that it would be good to have something similar to the kingdom. Like, you come to a certain area, you press a button and it will spawn a building. You don't really build it from blocks. So I built that system first, and I stuck in the wall. And it didn't feel that great. And I tried to experiment with other systems that's similar to like Minecraft or Terraria, where you actually build stuff from blocks. So it's kind of like experimentation at this point. The game is like very, very early in development stage, so a lot of here is like prototyping. Mm-hmm. Looks like my character's stuck in the wall. I'm just gonna restart. So yeah,
mm-hmm. Like I think what I see here is like there's like a ton of really solid groundwork that you have, and like a lot of systems seem to be like in place, and like yeah, the fact that you can go do jobs and you've been thinking through these systems really does seem like there is quite a lot that exists already. And so actually maybe to add on to that question a little bit is like, what's one system that you're really excited to implement or you're really excited to see, but hasn't really started up yet?
Yeah, so I think all the NPC interaction would be pretty cool. There's like no interaction at all, but like when, it's a simulator-based building game. So like once you build a base, it would be cool to see how the NPCs have their own like, life schedule, how they interact with each other. If you like bought, for example, equipment from blacksmith, you pay him money, and then he can spend this money to decorating his house and stuff like that. Or after hard work during the day, like all the NPCs go into like the tavern and spend money on like alcohol or something. So it would be cool to have like some simulation like that. That's why I'm like having a really high emphasis on AI, making it like trying to make it ergonomics. Like it will be easier in the future to describe all this complex chains with like a simple blocks that can be reused. And it's not here yet.
Or I was just gonna say that's like sort of what I'm thinking, is because like as I see all these complex systems interacting with one another, it makes a ton of sense that you'd have like an NPC like high level layer that the player experiences, where they walk into a village and they see stuff happening. It's not just the one lumberjacks on their like path back and forth from the tree. And so that's really cool to hear.
Cool. Anything else?
So I think that's all for questions for now. I would definitely love to see this as progress continues in the future. And so I know you have a Discord server. Looks like you have a website as well, so people can go check that out. So Vlad, thank you very much for showing this off, and I hope to catch you again next time.
Cool. Thank you for giving me the opportunity to talk about it.
Absolutely. All right, we'll be back in just a second with Kvark, who's going to show us a little bit more about Blade now that they've got some stuff fixed.
Looks like we're live.
Yes.
Just
all right,
wanna
we're back. Yes.
Finish on a good note. So nothing was particularly broken. Something with the asset confused the picker. I don't know what, but this is the same scene, the same code. And I'm just like dropping things on the scene from my right pane, which are you can recognize the famous Kenny's assets in here. So these are like things dropped here. Like I can select it, I can move it around. You can see that there's the coordinate system is a little bit offset from the actual object, because that's how Kenny's assets are made. That's not because I'm doing something interesting. But yeah, I can scale it. I can add objects, remove objects, rotate, and then save the scene. I can like select an object and delete it from the scene. So the TLAS, the acceleration structures, are like updating every time I change anything. And you can see nice ray tracing artifacts whenever you move things, which I'm going to work on. But yeah, scene editing works. I can compose scenes and load them. So that's all I wanted to show. Thank you.
All right, perfect. Yeah, and it's just cool to see that all coming together. And yeah, I mean, also just being able to play with it and kind of load in stuff and then see, because I guess like when we look at one scene, we get like one view, but like seeing the objects here kind of is definitely like a little bit different. And so kind of seeing how stuff looks when you move around. It's definitely, I mean, for objects, it's not as much artifacting as I thought it would be. I guess like when you're moving around the world in 3D, it's a lot different than when you move the object itself. Yeah.
Oh,
it looks so
yeah,
cool.
Everything versus just one object artifact. Yeah. We'll get there. But even like this, if you look at the shadow beneath this guy, this already looks like it's global illuminated, even though there's just one ray cast. Like you don't get this shadow on a rasterizer if you do an editor. And this is already pretty cool.
Okay, awesome. Oh yeah, good to see that this is all working out here. So again, thank you for showing off, and we'll catch you next time. We'll be back in just a second. So we are back for the final presentation of today. Now we have Ida and C12 here to present a game that they've been working on called The Seeker. And so I will hand it over to both of you.
Yeah, maybe I'll try presenting. Wait, share screen.
Sounds good. Yeah, we'll take a look at that.
Actually, well, maybe it'll be better if Ida just shows the files on present, because I'm not sure.
Yeah, I have
yeah, if you could just play the trader and Yak maybe as a kind of
okay, you can talk about the game meanwhile.
Yeah, so I just want to kind of talk about the game from like a more kind of artistic and lore perspective. So The Seeker is a game that I'm working on together with Ida, and there's also one pixel artist on the team and a few of my kind of sound designer and music friends, because that's like my background, which has some relevance to the game that I'll get into a bit later. So the idea behind the game is that it's a sci-fi 2D kind of Metroidvania style game where you play as one of the first settlers on an alien planet that was just discovered, and the alien planet is all covered by ice, kind of like Hoth from Star Wars, and all the creatures are living in like deep cave systems below the surface, and there are a lot of things to explore under the ground, and the kind of vibe that I would like to express with this game is kind of like playing something like Red Dead Redemption, or one of these kind of more sandboxy games where it's kind of the format of a Metroidvania, but at the same time you have much more freedom, and the world is much more kind of organic feeling, where you don't really have any specific like bosses or kind of scripted events, but it's more like you engage with the ecosystems there, and kind of a bit more like something like Rain World or something like that. And on top of that, there's also a bunch of like the combat system is much more similar to something like Risk of Rain, for example, where it's kind of a combination of a very calm atmosphere in the actual like scenery with like very hectic combat with a lot of like explosives and stuff in the actual combat part of the game. And then on top of that, the game kind of has like multiple layers to it, where the kind of surface layer of the game is what I just described, like a kind of adventure game where you explore a planet and stuff like that. But on a kind of more technical or deeper level, it's kind of like an experiment that I want to try out based on an idea that I got interested in my sound design background, and it's an idea about essentially sounds and visuals ultimately being all about mathematics. And just like in music, for example, you have the idea of root notes and key frequencies, where let's say you have a sound playing at 100 hertz, and you can take that as your root, and then once you multiply it by 2, for example, you get octaves, and if you divide it by 2, you get octaves as well. And the same you can apply to, for example, hertz, which is the same oscillation, or FPS, which is the same oscillations per second in animation. And then you can do this kind of octave transposition to kind of sync the audio to the animation. So in this case, we have the audio root frequency at 48 hertz, and then all animations are playing at 12 FPS, which is exactly 2 octaves. So 2 times divided by 2 below the musical root note. And then, so all music in this game kind of is based on the 48 hertz, and then all the kind of harmonies are derived in that mathematical sense. And similarly, all the visuals are kind of synced to the 12 hertz kind of thing. And then the same thing is happening with like the tempos of the music. So the tempo of the music, the BPM, is also a number of repetitions per second or per minute, and that is also synced to those previous two. So in the end, what's happening is that kind of the whole thing is kind of beating to the same clock, and you as the player become a kind of instrument in this whole thing, and everything you do is kind of by definition synced to the tempo. And it's not meant to be a rhythm game where it's not meant to be super obvious, but it's kind of an experiment in trying to find out how that kind of super synchronized experience would feel, and what kind of mental state it would put you in, together with like the visuals and all that, kind of trying to create like a sense of wonder and kind of a meditative experience where you on one hand explore the planet, but on the other hand you're presented with like this mathematical structure that you're kind of exploring as well. So that's kind of like the kind of artistic and lore explanation, and then maybe Ida can tell more about like how we're tackling that from the. Oh yeah, there's some more gameplay here. Here without the backgrounds. So it's all like super early on. And you can also, yeah, maybe this as well. This one has the backgrounds, but it's kind of missing some more context. And yeah, I think that's kind of it. Is super early in development. So, and here's some more like animations that we have to player.
So first of all, I want to add something to your comments about the game design and why I'm personally kind of inspired for your game idea and why I decided to join the project and work with you. I really like the kind of aesthetic and vibe that kind of reminds me of a game like Hollow Knight in its kind of mystical cave exploration. And I know that you are really into like you said, these mathematical ratios and fractals and things like that. And the way you describe this mental experiments of trying to really synchronize all the sounds, make them with really perfect timings, and have the visuals and the music and the sound be following mathematical ratios and things like that. I'm really looking forward to how that's going to turn out, because I think it's going to be a bit of a psychedelic experience, if you will, where you can kind of feel the fractals and the mathematics of the world kind of ticking like a clock. Yeah, and this brings me on to the thing that I've been working on, which is a very clever asset-driven animation system purpose-built for this game in Rust and Bevy. So what we have is we can create asset files that are scriptable. And our game is running at a fixed time step tick rate of 96 hertz. We chose 96 hertz because it allows us to have a lot of granularity for subdivisions, but also it's a clean multiple of, like C12 said, the design frequencies of 12 hertz and 48 hertz for the music and the visuals. And what we can do here is we can create different animations that are by having the texture atlas. For example, yeah, this is the raw graphics. So for example, the idle animation, you can see for the player or the run animation, but there is this script file that tells the game how to play it. And in this script file, you can set some metadata, and the whole format and the animation system for our game is designed to allow everything to be scripted and coordinated and orchestrated at very specific timings, so that C12 can implement this artistic vision, where the sounds and the footsteps and the frame transitions of the animations happen with perfect timings, with perfect multiples of different ratios. So, for example, this tick quant parameter means that this animation is always going to start to play as if it's synchronized and to a multiple of 8 ticks. So the animation is going to advance 1 frame every 8 ticks. So that makes 12 FPS. And this tick quant means that whenever you press the movement key and the game transitions to this animation, is going to kind of round and quantize the current tick number to a multiple of 8, so that the animation always plays in lockstep with other animations. And we can add these script actions to do things at specific conditions, and it's very flexible. I use Serde for this. We can go to the file format implementation is written with Serde structs like this. And here you can see how, like, we have different run conditions. These are the triggers that trigger specific actions in the script. So, for example, a certain tick number, or a tick quant is for like a periodic thing. Like if you say run every n ticks 8 plus 2, that is going to run on every multiple of 8, but like offset by 2. So if I uncomment this is going to change the color to red every 8 ticks, but like offset by 2. So like on tick number 2, on tick number 10, on tick number 18, and so on. And this is going to change it back to white. And this way we're going to make a blinking effect. And it's going to always be perfectly synchronized with the tick rate. So, for example, if I run the game right now, wait, I mistyped. You can see that if we have wait, what happened? Again, things break when you want to present them. What happened here? Yeah, so like when you get the damage, you have this blinking effect. So if you like, you can switch between idle and run and apply this damage effect. And this works by, if we look at the Rust code, you will see it's actually really elegant. I really like it. Right now I have this placeholder system for testing where I just check for different inputs, like different key presses, and I tell the animation system to play a specific animation. So for example, the idle animation or the run animation. And we have these slots. The slots are like modifiers, like Boolean variables that you can set for the script. You can say like direction left, it becomes true or false, or direction right becomes true or false, or damage becomes true or false. And here in the script, we can do things like run on slot enable, direction left, and change to a different frame index, set frame now and go to frame 0. And on run on slot enable direction right and jump to frame 10. And this way we can like do different sub loops and different kind of things in the animation, and it's all orchestrated from the script file. This way the Rust code becomes very simple. The Rust code just needs to set the variables. It needs to tell the animation system which animation to play, and then control the variables for the scripts by setting the different slots to true or false. And in the script, we can orchestrate things by saying, like on a specific animation frame or on a specific tick. Like I could, for example, just add a new script action here and say run on tick 0. and do something like action set sprite flip or set sprite color, and set the color to green, just as an example. And then, for example, run at milliseconds, say 2000, and we'll set sprites flip to flip the sprite along the x-axis, or let's do the y-axis just to make things more interesting. And when I write this, it's in the asset file, so I don't need to recompile the game. I can just run the game. And when I go here, wait, what happened? So I'm now in the idle animation. Oh, something's broken. Something's broken. Oh yeah, we have. Oh, it's run at tick instead of run on tick. I miss. It's a syntax error in the animation file. So see, now it's green and it flipped because like we queued up those actions in animation. So now I can like play. Yeah, if I reset the game, you'll see it will start playing the script, and after 2 seconds it will flip. So you can use these script files to basically implement any sort of artistic effect by changing the color, by flipping the sprites, by changing the transforms. We also have script actions for directly manipulating the transforms in the engine, so you can make things move around. If you want to make like a vibration shaking effect, you can do it from the script by changing. So like, for example, instead of doing run at milliseconds here, I can do, for example, run every n ticks, and say every, say, 64 ticks, I am going to set the sprite flip to true, and every 64 ticks plus 32, like to offset it, we're going to set it to false. If we run that now, you're going to see how it's going to alternate between the two states. It's just flipping up and down. And I can also add a randomness to it by saying like something like RNG percentage equals to 50, or let's say 75 for this one, and 25 for this one. And when I run it now, oh, I think oh yeah, I should have, it's not in quotes. Yeah, it's a syntax error again in the script. So when I do this, now it's going to have like a random chance of flipping every 64 ticks. See, sometimes it does it, sometimes it doesn't. So you can have also randomness in the scripts like this. So this is very powerful because we can add any sort of custom actions to our animations, and we can control the exact timing. So you can say at tick number 16, you should play a footstep sound. And at tick number 8, you should play this other like footstep or jingle sound, and but you should do it with a 50% probability, so that you don't do it every time, and it's like a random. And every 5 ticks, you should like change the color of the sprites, and then every other 3 ticks, you should change the color of the sprite and do like different effects and different things like that. And for the movement, we can also make it synchronized to the tick rates by, say, for example, changing the transform, doing like a physics move on the character controller from the script, so that the enemy is walking in perfect cadence with the music and the sounds, and you can play the footstep sounds and the music and the frame animation transitions, everything perfectly synchronized to the tick rate. it's going to be very interesting. And I developed this system specifically for this game to allow C12 and the artists to realize this artistic vision of having these elegant mathematical ratios of overlapping visuals and sounds. So we're going to be doing different visual effects and different sound effects from these scripts, orchestrated with very precise timings. And the next step I'm going to do here is implement a custom audio system, because we realize that Bevy audio, it does not have the consistent timings we need. If you just play sounds from Bevy, sometimes they will be a little bit delayed, they'll be a little bit offset, they'll have kind of unpredictable timings. So I'm going to make a custom audio stream that feeds into Bevy audio that is going to also be synchronized with our scripting language here, so that we can play the footsteps and all the other sounds and so on with perfect timings, and I can generate the audio stream in real time with the tick rate of the game. It's going to be very interesting, and I'm really proud of how this turned out, because it gives so much creative control to the artists. It's asset-driven. You don't have to change any Rust code. The Rust code for the movement of the player and the character controller, it can just set these different variables to true or false for the scripts. And you can do different things in the script. Like here, for example, we are looping between frame 0 and 9, and that's when the player is facing to the left. And when the player is facing to the right, we'll loop between frames 10 and 19. And when the Rust code sets direction left to true, we are going to jump to this frame index. And when it sets to direction right to true, we're going to jump to this frame index. And then we can do a blinking animation, blinking effect, and other things from the script. So it's kind of a really convenient scripting language almost, but it's not a programming language. It's a declarative asset file format that is based on TOML. As you can see, it's just TOML syntax. And I load it as an asset with Serde. And then the game code will parse this, and it will queue up all the different actions. If we go to script.rs in the game, you can see that like I have this extensible trait system which allows us to have different variations on this script format. So we have the basic scripts which are used for things like level events. You can have a general purpose script if you want to make something like a cutscene or something like some background events happening on the map. So say, for example, you want to say that after 5 minutes, an enemy should spawn, or in like every 50 seconds, some enemy should spawn or some NPC should appear. You can do that from a script. But we also have the animation format, the one that I was just showing off, which is an extension of the basic script format. And if we look at assets animation.rs, you can see that here I define the animation extensions. So a new set of run conditions and actions that are specific to animations. And I'm using this special extended script struct, which combines the general purpose scripting stuff with the animation specific stuff to create an enhanced combined extended file format that supports both of them at the same time. So you can use any of the parameters that are available in all of the different scripts, but you can also do animation specific things like changing the frame and changing the sprite color. And it's very composable in this way. I implemented it with Rust traits. You can see the traits here. So I have a trait script asset, which has all these other traits to make it extensible. It's a little bit over-engineered, but I think it's worth it. So it can have like settings and access to arbitrary Bevy system parameters to do different things. And we can have a trait for the different action types and different run conditions and the different parameters that you can have in here. So I'm doing some very clever Serde trickery to kind of combine everything into one format. If you look here, I'm using all of these attributes with Serde renaming and tagless enums and flattening between the different structs and so on, so that it can be very intuitive for the artists to write. They don't need to understand the structure, the underlying structure in Rust. Everything is combined together. We have like this common script which flattens these several different structs to combine all of their fields into one, so that here in the actual file format you can specify the run condition, extra parameters, the action, and so on, and you just do it under one script section like this. And all of it is merged together and then parsed by Segde into this struct, which automatically generates all of these separate substructs, the nested structs for the run conditions and the parameters and so on, and the actions. And here's the implementation. So I have this tracker. This keeps track of all the different actions that are queued up. So these are the actions that are supposed to run on specific ticks, or the periodic actions on different slots, enabling, disabling, and so on. This is like the internal state of scripts. And here is like the initialization and update, which will take the Rust structs that are loaded from the asset file and initialize all of this stuff. And then every fixed time step update, it will iterate and it will go through here and it will check the current tick number and the timers and so on, and add different actions to the queue to be performed. So the script driver system in Bevy that I have in script.rs is generic. You will see like I have script driver system, which is generic on the trait, and it will use this clever Bevy syntax to access arbitrary parameters from the ECS. It will load arbitrary data based on the associated types of the traits, and that's how I can make it generic. So I can have different asset types. I can have an asset type for my general scripts and an asset type for my animation scripts, which is the extended format with additional actions and run conditions and so on. And here I have an API that is similar to Bevy's own animation API, where I have a ECS component for the animation player, and you can tell it play handle and give it a Bevy asset handle, or like play key or something, and it will transition between playing, stopping, loading the asset, and so on. And it will drive this whole thing. So all of this complexity is conveniently hidden under the hood here, and C12 and the artists can just work with the asset files and not worry about any of the Rust code. And it's really convenient because if they want to make certain sounds or certain visual effects play with very specific timings and coordinate everything to make it feel really good, they can just do it from the asset files declaratively from this TOML-based file format without touching any Rust code. You can see how the animation stuff also has its own sprite animation tracker, which extends the common script tracker, and it does things specific to the animation playback. All of this is put together using these special Rust traits. So I'm using the Rust type system to allow me to have an extensible file format. In the future, I could create another asset format that is based on the same architecture for other things. So right now we have sprite animations, but say in the future I want to do some sort of gameplay scripts where on something like different weapon attacks or like enemy AI or whatever. So I could just do something like enemy AI script formats and implement all the Rust traits and extend the common scripting format with additional AI specific actions for pathfinding or whatever. And we'll have a new asset format that has the same syntax and supports the same common things like run at tick, run every n ticks, run at milliseconds, and so on. All of these common parameters will still be supported, but I can extend it with additional AI or pathfinding parameters in the same way as I did here for sprite animations.
Yeah, and maybe just I'll just add one more thing, is that we're trying to basically make this game as open source as possible. So currently the entire code is under the same license as the Bevy engine. And that also guides a lot of the decisions about how to organize the code, etc., so that it's very easy for other new contributors to start adding stuff. And we're kind of trying to treat this game as a kind of a creative canvas where there are the certain mathematical rules that I kind of set out, and then anyone can just make their own things based on these rules. And it's already like the most obvious with the music sound part of the game, where we're essentially all making, like me and a few friends are making tracks and then sharing the individual parts, individual stems of these tracks. And since they're all using the same tunings, they're all compatible with each other. So it's like a massive remix thing where everybody can pick and choose which parts of someone else's track, etc. And it's like a massive growing pile of music that's just being produced. And I would like to have the same for other aspects as well, and allow as easy as possible of a community creative thing happening. So yeah.
All right, perfect. It's super cool to see this. I think I really like this focus on being able to create some kind of file that you can go through and be very I guess terse in what you're saying, but have a lot of complex things that can happen from it. And so it's really cool to see. And I guess even as an animation designer, being able to go through and try different things, put different things together. I feel like a lot of games definitely follow the same path when they go for animations and how you go about that process. But this one seems a lot more dynamic. And so I'm quite interested in taking a look through the code that sets this up. And so you mentioned the whole project is open source. Are you thinking of maybe extracting this idea of taking the assets pipeline and abstracting that into a crate that other projects can use as well?
I've thought about it, but right now the code is kind of quite interentangled with some things that I've made for this game. It's, for example, instead of using Bevy's usual fixed time step, I have my own fixed time step because I didn't really like the way that the structs are represented in Bevy. So I kind of re-implemented a few foundational things. And also, I'm not really sure how I can make this project independent, because a lot of the actions that we have here are represented using Rust enums. Like you can see, I'm just matching on an enum to implement the different things like set frame next, set frame now, set ticks per frame, these different things. So naturally, we are going to have a lot of things in this syntax, in this file format, that are going to integrate with all kinds of different game-specific parts that are kind of specific to this game. So I'm not sure how I could pull this out into a separate crate to generalize it. I think I could, but you wouldn't be able to use it just as a Rust crate. You would have to fork it and add your own commands and your own integrations into to do your own game-specific stuff if you're interested. So I think the most realistic way to make this useful for other people is not so much to try to make it into a Rust library with some sort of API that lets you hook into it, because it's supposed to kind of integrate with your code base. You're supposed to have these kind of enums that define all of the custom things you want to do from your scripts. And I don't think you can do that without modifying the code. So I don't think this would be that useful to try to make into a crates.io thing that you can just use as a dependency. I think I would much rather do it as some kind of template repo or something like that in the future, where you would be able to, I could maybe take the code that we have, strip out all of our custom actions here, and publish that as like a separate GitHub repo or like a gist or something. And so people can copy paste it and insert their own custom actions to customize the file format for their specific games.
Yeah. Okay. Yeah, that's super cool. yeah, I do like that idea of kind of like making a template that people can start from. And I mean, even if it's a template for like education and kind of learning what the process is, that would still help people, I imagine. All right. Well, yeah, thank you for showing this off. It's really cool kind of seeing the background of what's happening here. So I'll make sure to include links to the Seekers GitHub repository and Discord server and all of that in like the blog post that I'll put it afterwards. But for now, we are at the end of the meetup. So thank you both for showing this off.
Thanks for having us.
Absolutely, absolutely.
Thanks for
We'll be
having
back
us,
in
yeah.
just a second with the closing. All right, I've been putting together the blog post for today's meetup as we're going along. So hopefully that should come out relatively soon. I do want to say, if you want to stick around and chat with some of the speakers, I just want to hang out, come by the Rust Gamedev Discord in just a minute. I'll be hopping into the Hangout chat there, and then I'll post a link for anybody else who wants to join as well. So thank you everybody for coming out. If you have a product you want to show off, definitely get in contact with me. I'd love to see what's been going on. And also, we had like quite a few new products this month, and so it's very cool catching up with what's been going on. So anyways, thanks for coming out this month, and we will see you next time.